For today's video, we are talking more about equations, what they mean, how to use them, how to think about them, and all of that. So our learning target is I can represent equations with tables, graphs, and descriptions. Please write what you already know about this topic. And write down the date that you're watching this just to keep yourself organized. When you're pause the video here and when you're ready, restart and continue with the video. So today we're doing what we've been doing, which is looking at tables, graphs, equations, descriptions, all of these things. And we are starting today with the equation. So the equation representing how many cookies C Tashayla can cook in T minutes is C equals 5T. Here, C is standing in for our Y, and T is standing in for our X. So if you look at that and you're like, ooh, C and T, that doesn't make me very happy, you can always rewrite this as Y equals 5X. Remember that the Y is one that's by itself over on one side, and then the number, the variable that has a number next to it and all of that, that will be our X. Okay? Looking at this equation, we want to be able to look at this and immediately know what this equation means. So for example, C equals 5T. We know that that means that our rate of change, that is the number multiplying the Y, or multiplying by the X. Ooh, something happened. In this case, that's 5. Our starting point is any number that's being added. In this case, we don't have 1. That means that our starting point would be at 0. Now we can draw a table. We can use T and C, or we can use X and Y. And our table is going to help us figure out what points we can plot. So if Tashayla has been cooking for 0 minutes, then she will have cooked 0 cookies, because 5 times 0 is 0. At 1 minute, well, 5 times 1, remember we can just put these things in for the X or the T in my equation. 5 times 1, that just gives us 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. So we can see here that each of these fits the formula. C equals 5T. Each of our T's is being multiplied by 5 to get our C, or our X and our Y. So our description, if I were to describe this in terms of the story, she can cook 5 cookies each minute. So my description is that Tashayla cooked 5 cookies per minute. And we can see that here, 0 minutes, 0 cookies. 1 minute, 5 cookies. 2 minutes, 10 cookies. 3 minutes, 15 cookies. All of that is represented in our table. So the next thing we want to do is graph this equation. So remember that my numbers on my table, that always represents my graph. So my first point is 0, 0. I'm going to start by labeling. This side is minutes, which is my X or my T. And this side will be cookies, which is my C or my Y. To put together our scale, well, our T, 0 to 4. So I'll just go 0, 1, 2, 3, 4. And on the bottom, I go from 0 to 20. So I'm going to just count by fives because I can see that this counts by fives too. 0, 5, 10, 15, 20. So I'll just count by fives. 5, 10, 15, 20. Now I can graph all my points. My first point is the point 0, 0. Next is 1, 5. Then 2, 10, 3, 15, and 4, 20. This was easier because since my table it counted by fives, I just counted by fives on my graph. I draw a line through this. And there's my graph. So the last thing I need to know is whether or not this is proportional. Looking at the graph, I know a proportional graph has a constant rate and it goes through 0, 0. So that's really clear. This has a constant rate and it goes through 0, 0 on the graph. However, I also can tell by the equation, y equals 5x. Remember, the equation for proportional has to look like y equals a number times x. My equation has that. My table also, it shows that it's proportional because every time it's just times 5 to get from the top to the bottom. So every way that I have to check, I can see that this is proportional right away. So my answer is yes. Okay. Let's try another one. The equation representing how many hamsters H Kyla owns after T months is H equals T plus 2. Remember, if you really dislike the H's and T's, you can set this as Y equals X plus 2. So I want you to start on your own. See if you can fill this out for the rate of change, starting point, the table description, all of that. See if you can do all of that on your own, pausing the video here, and then restart when you're ready. Hopefully you have attempted at least the parts of this problem that you can. So now we're going to do it together. The rate of change is how much it changes each time. This is the number being multiplied by the x. Looking at this, I see that there is no number being multiplied by the x or by the t. There's nothing here. That means that my rate of change, how much it's increasing each time, is just 1. My starting point is where we start, whatever's being added. In this case, I see that I have a 2 being added. So my starting point is 2. Now I can make my table for t, which is x, and h, which is y. And just like before, I'll just do 0, 1, 2, 3, and 4 up for my x, for my t. Okay? All right, so at 0 months, I would do 0 plus 2. That would give me 3. So each time now I'm just going to put in my number for x or for t in my equation. So 1 plus 2. Oh, and actually 0 plus 2 is just 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. And 4 plus 2 is 6. So looking at this, let's put this in story of Kyla's hamsters and months. So at 0 months, Kyla has 2 hamsters. After 1 month, Kyla has 3 hamsters. She likes hamsters, so she gets another one. After 2 months, she gets another hamster. Now she has 4. At 3 months, she has 5 hamsters. And at 4 months, she has 6 hamsters. So my story, my description would be that Kyla starts with 2 hamsters. She gets another every month. That's the story. She started with 2 hamsters. She decided she really likes hamsters, so she gets 2 more hamsters each month. So now we can graph this situation. So here I have T in months, and on my other axis, I have H for hamsters. Okay? So for my months go from 0 to 4. So I'll go 0, 1, 2, 3, 4. And then my hamburgers goes from 2 to 6. So we always start at 0, but then I can just count by 1. So 1, 2, 3, 4, 5, and 6. So now I can graph my points. First point is 0, 2. Then I have 1, 3, 2, 4, 3, 5, and 4, 6. Remember, my points came from each of these pairs. So now I want to know if this is proportional or not. So your first question that you are putting into your check for this video is I want you to tell me, is this a proportional or relationship or not? Looking at the graph, looking at the equation, looking at the table, is this a proportional relationship? Your answer should be yes or no. Don't add other words, just yes or no. This is your first question for this check. Hopefully, after we did this, your work and my work matched up. And we both have our graphs and tables and equations and everything are the same. All right, we're going to do one more here. This equation representing the temperature in degrees D in Minneapolis T days after March 5, 2014 is D equals 5T minus 5. Again, if you hate the D's and the T's, you could say Y equals 5X minus 5. This one is a little more complicated than the other two we've done. So see if you can do it on your own. See if you can what you can fill out. Sometimes starting with a table would be an easy point here in the graph. So see if you can do that, and then restart the video and check what you were able to do with what I do. So our rate of change is always the number next to the x. So that's 5. Our starting point is whatever is being added. I don't have anything added. I have something being subtracted. So that means my starting point is minus 5, negative 5. So now I'm going to fill in my table. I have the time, x, and I have my degrees, or my y. I'm going to do the same thing, 0, 1, 2, 3, and 4. And now we're just going to plug each of my x's in for this x here. So if x or t is 0, if t is 0, I would do 5 times 0, which is 0, minus 5. 0 minus 5 is negative 5. For when t is 1, or x is 1, I would do 5 times 1 minus 5. Well, 5 times 1 is 5, minus 5, that's 0. For when t is 2, I would do 5 times 2, which is 10, minus 5 is 5. When x is 3, I would do 5 times 3, which is 15, minus 5 is 10. And when x is 4, I would do 5 times 4, which is 20, minus 5 is 15. Again, all we were doing is putting it in for x or for t. It's the same thing either way. Putting it in each time, multiplying that number by 5, and then subtracting 5 from my answer. So here, now we can look at our table and think about what's going on. At 0 days, my temperature was negative 5 degrees. After 1 day, my temperature was 0 degrees. After 2 days, my temperature was 5 degrees. After 3 days, my temperature was 10 degrees. After 4 days, my temperature was 15 degrees. So what this means is that on this random date, the temperature was negative 5 degrees. And then each day, temperature went up. Well, it went up 5 degrees each time. And that's what was happening. So now I can graph this. My T in days is over here. And my D for degrees will be over here. Now, one thing that I see here is that I have a 0, -5. So what I actually need to do is I'm going to, and the reason I'm doing that is so that I can have negative numbers. So my 0 will be there. And then I can have -5, -10, -15, and 5, 10, 15 over here. Then I'll have just 1, 2, 3, 4. If you drew this graph and you just skip the negative part, that is also okay. So now my points will be 0, -1, 0, 2, 5, 3, 10, and 4, 15, making a straight line there. So my second question for you, for your second question for this check, is I want you to tell me yes or no, is this one a proportional relationship? Hopefully this helped you think about what the equations mean and what's happening in them. Please let me know if you have any questions and have a great day.